And welcome to my talk about Kubernetes, the platform for platforms. I hope everyone is having a lovely evening so far, and I hope you enjoy the talk. Yes, this is a blurb. It's basically the same blurb as what you had on the website about me. I work at Electric Payments, and I'm a DevOps engineer that works in the platforms team here at Electric. Today, we're going to have a little adventure with taking one from a little no-needle Docker container into the land of Kubernetes. Then we're going to cover some general concepts of Kubernetes. Then I'll touch on to what platforming as a concept is, and then why I think Kubernetes is a great tool to achieve that as an objective. Okay, so we're going to begin our little adventure here with this is a Docker image. I hope some of you know, or if some of you don't know more than this stage, it's alright, I will be able to come along with the adventure. So usually you have like some kind of workload. It can be an API and a front end or whatever. So in this talk I'm going to be talking a little generic. So it can be kind of any image for the purposes of this. So we have our little image, but now we need it to run somewhere. So how are we going to do that? So I'm not going to cover getting a Kubernetes cluster in this talk. This is more just assuming you already have one. So now this little image needs a house. So we need to take the image into a running container. And in the Kubernetes land, you can do that with things like a deployment or a stateful set or a daemon set. And here is kind of how it would look in terms of the YAML or the manifest created in the cluster. And yeah, we just have a bit of YAML here. So now we have a house for the container to live. So now we want things to connect to it. So that is now in a suburb, so it wants to be part of a community, so that things can talk to this API. Maybe you have some back office thing where you need your front end to talk to the API. So now we need it to get access to the rest of the suburb. And in Kubernetes world, this is going to be a service of some kind. And you use this thing called like a selector and some label to and this is linked up in the deployment. If we look 2 slides back, the labels will have and line up in here, and then the service will connect in to that label. And then that gives some information about that we want 80 to be the destination port of the pod, but we want 80 to be the thing that will be listing on the service. So other things can hit this web app on port 80 if there's a wish to inside the cluster. So now things inside the cluster can talk to it, but what if you need it now to, let's say, be accessible from the outside world, outside of the cluster? This is now where we get into like Ingress territory, where you can like define what kind of path the task has, and like HTTP layer 7 kind of configurations that like service 1 needs to go to this particular path on the container, like service 1 or service 2. And this is like a way how you can define everything that is running in the container in Kubernetes, how it can get access from the outside world. And like in this case, we want myapp.example.com to be the host name that will be listing for this particular service. Okay, so now that's just a little adventure of taking a container all the way into some Kubernetes context where something can talk to it inside the cluster and something can talk to it from outside the cluster. But what if we don't know much about Kubernetes? So here's just a little diagram of all the components of Kubernetes. So on the node side, we have the kubelet that basically just receives all the instructions from the Kubernetes API server side, and then it will use all the information about how to execute itself. And there it takes care of things like mounting volumes and giving it the pod secrets and all of that and stuff. Then on the API side, you have the API server and then some that the Kube API server is the way that you can interact to the management side of the cluster. So that's where you apply your manifest to. This Kube API server instructs other components like schedulers and the kubelets to do the actions that you have defined in the manifest form. So here is just some descriptions of each. What will be interesting for a bit later is the controller manager. This is where Kubernetes tells how keeps track of what all the things are happening in the cluster and then makes decisions based on what is the state of the cluster versus what your desired state is for the cluster. And then the controller facilitates bringing things back into the correct state if it has drifted for some reason. We will return a bit on that topic a bit later. And on the node, you just have two things, which is the kubelet, which I mentioned a little bit earlier, and then the kube proxy. And then this thing, the kube proxy is the part that allows the networking between various services and pods to be routed to each other and allows connections between different nodes to be able to be to facilitate the traffic from one pod to the next or from outside to the right pod inside the Kubernetes cluster. Okay, so one really cool part of Kubernetes is that it has these controllers that are checking the desired state all the time. And so you set some desired state against the API, and then the control plane schedules the resources if that is different from your current state by any means, and then it tells the control plane that it has done so. And then every now and then periodically, or continuously rather, the control plane checks, has any drift happened, yes or no, and then if nothing has happened, naturally nothing needs to be done. But if some drift has happened, then it will attempt to do the reconciliation back to the original desired state that you defined in the control plane. And then this just loops continuously, keeping track of all the resources, and helps with automatic healing in a sense by trying to reconcile things that you say all the time. So desired state versus actual state. Desired state is if you think back to those YAML files we looked earlier, that is what you tell Kubernetes the state of your world has to be. And then Kubernetes will now, that's the desired state part, and the actual state is what is going on in Kubernetes right now. And that could be the same or different, but then you'd use that flow diagram over there would indicate where what will happen. Yeah, as I mentioned, one step. Okay, so here's an example of how we get to what could happen. Is let's say you have three of these pods that we have, or these containers running that we've had from the beginning. Now, one of them has a fatal runtime error and is dies. Now, Kubernetes will now notice that your desired state is 3 replicas, but the actual state is not 2 because one of them has categorically died for some reason. Now it will attempt reconciliation, which is just to schedule a new pod and then the state of replicas will be back to 3. If it has a runtime exception again, this loop will just continue indefinitely. And so that's why you will need some alerting or something like that to catch when the reconciler can't actually help your problem anymore. That's when you need some extra help from that. And controllers just is the thing that facilitates this in the Kubernetes world to make this continuous checking and then just continuously runs in the background to make sure that what you want is actually happening in the cluster. And this is a great part for why I think Kubernetes is valuable as a tool, to be considered as a tool for building platforms with, because it has this drift detection engine kind of already built into it. So if you use the API of Kubernetes to define your band of how you need your application to be running in entirety, then you have no drift detection on that. which is like pretty hard. In an Ansible world, you would have to continuously be rerunning your playbook to be able to get a similar kind of result. And then would you then run that as a cron job for every minute? And then instead, like, it's really a little bit more difficult by not having some kind of drift detection engine helping you. So now we get to the idea of platforming. So this picture is why I think platforming is a cool idea. Because we've often seen this happen where there's like a perfectly good path, but yet people always choose to cut the corner for some reason. Now, this is a bit of a metaphor for like many things in the tech world, but like, for example, when there are like problems in production, you need to fix them quickly because customers will get upset, and then revenue is upset. So it has like this chain of things, so you kind of need to act quickly sometimes, depending on the nature of the problem, naturally. Now, then you could maybe do something manually or something that's like not quite using the right path, and now when you come look again months or years later, you don't know why this weird thing is just there. And now there's like this corner cut in the path. So how do we actually try and make that better? So instead of just like trying to provide environments where things are cobbled together and so on, that's probably wise to spend the time to think of what does your business use case or your environment or your context need in order to be abstracted away so that you can think about the problems that is relevant to your space. So like to take away as much of the pain to get infrastructure or environments or configuration going is to build these kind of yielded pathways for people to walk where the corner would have been cut off instead. So beginning with like, if you can standardize how you make environments, then it becomes a lot more possible to start thinking about how do we define like best practices for our context so that when new people come on, they can just they can have a very clear or supportive experience of how to actually achieve something and decrease like the anxiety or failure rate of people when they want to just be productive and try and add some new productive code or solve some interesting solutions. Now that you have some best practices in the picture, now you can, and that becomes quite a lot more easier to do automation because you have some kind of standardization around what you're trying to be building and figure out like what your like small blocks are that you need in order to facilitate your project, your environment. Then you can automate a lot of the painful touch points away to where you want sensible touch points where if you build it, creating or rolling out a whole new production environment, maybe you want someone just to like the thumbs that up to make sure that like the contracts are signed and stuff, so that we're not actually like wasting money before we actually spin out the stuff. Some places or touch points are kind of good where we can, as humans, decide is this kind of time to do this thing. We work in the financial sector, so we can't just willy-nilly make changes, and there are like times when you have to wait for freeze where you can't make any changes. So automation in our context is more around the touch points to get between the touch points automated as much because we need to collaborate with some third parties to actually enable a particular project. And so it can't just necessarily be as soon as the developer gets the git commit message to go all the way to production. But if your context works, then automation is great for that in that context. And now that a lot of things are more automated around the touch points, that actually makes sense for your kind of context. Now that enables you to have faster time to market because you're not worrying about how do I create these environments or these contexts for where my workload needs to run in. You can just ask for it in the sense of ask the platform to give you instantiation of this kind of environment. Then it simplifies those that need to get into the actual problem solving part into the real world. Now, that enables a lot more collaboration, because now you can be talking about, be sharing similar kind of basics with each other, and now you can like be thinking about like, what if we use the basics of different orders and different combinations, or try to tackle different problems because we have different means to do it than what one had before. And then all of this stuff just naturally leads to more innovation and the ability to get closer to where your innovation actually needs to be done in. And I kind of mentioned this, but the kind of platform I'm more meaning here is more like the internal platform for the engineers or for like the technical staff who needs to achieve some kind of function, some kind of objective, and to create like integrated tooling that like directly facilitates the needs of those people. And the clients of the like internal platform are the engineers, and then the engineers, these clients, are the actual clients of the company, for example. And then with that kind of relationship, you will be targeting the needs of your fellow engineers a bit more authentically by actually treating them as a direct customer and keeping that as an organic conversation going continuously, so that one can actually hear where the platform needs more work or more evolution into individuals. So now we're going from making shortcuts across the corner of things to having a gilded pathway where you have the right kind of guardrails to help you in a way to not like shoot yourself in your own foot, but get to like do what you mean type of thing, so that you can get on to what you really are passionate about and not struggle with infrastructure and stuff. So it's not just about what technology you use, it's ultimately about that you're trying to innovate how your teams and fellow members are interacting with each other and to create operational efficiencies and then therefore enable business growth by having less struggles in order to achieve what you want. Okay, so platforming, but with Kubernetes. So now, Kubernetes has this ability to be consistent with an extensible API. So like the three examples I showed you in the beginning with a service, a deployment set, deployment and Ingress, the structure of that YAML is the same. Just the words, the fields are different. But this now means you can use a consistent language and like domain-specific language, if you will, to define your land inside Kubernetes. And this is quite like a different experience if you like tried using Ansible and Terraform and all these different tools. You need different DSLs for different sectors, but what if one can now start to think about a platform where your fellow engineers can just think about like use the same kind of contract, same kind of interface to get the same kind of results, rather than now I need to understand Ansible and how this works. It helps unifying the experience a bit more to be. So that's quite a fascinating part of it. Resilience and threat detection, as I mentioned a bit earlier. Portability for Kubernetes. This is just true for containers in general. When you're running containers, you're a bit less concerned about how those containers are running. So like what type of VM it is, or what kind of OS the nodes are running, they become a bit less important. You're starting to think more about your bundled packages that you're bundling as images and making sure that how you're comprising those images together is sensible for your use case. And if you need to move from like on-premise Kubernetes to cloud Kubernetes, you'll be able to reuse a lot of the same primitives that you've built for the one to the other environment, with some differences to facilitate the different type of context you're in. Then the extra cool part is that everything is declarative, because it's using YAML files or different kinds of ways that you can package those YAML files. So this is just what I was meaning, where the structure of all of this looks very similar. We have like an API version describing some section of Kubernetes API, and then a kind of a resource of it. Then, and how this resource is going to be, how it will work, or what the state is defined inside the spec of the YAML object. There are some kind of tools to help facilitate making these kind of abstractions with the Kubernetes world. So Customize is one of the kind of tools where you can create patches for your kind of YAML. We have a base YAML, and if you want to apply different kinds of context to it, you can use different kind of patches. Here is an example of staging and prod, where some configuration is different depending on the context you're in. But this is kind of how one can reuse the same kind of language to kind of facilitate different kind of environments without redefining everything and keeping it all consistent. Another one that one can use for this is Helm charts. You can comprise Helm charts in lots of many wonderful weird ways where you can ultimately it just works very similarly to like how you would think of apt packages, where the apt package contains all the things that are required from binaries and the configuration to make those binaries work on your local machine. And the Helm chart is the same kind of thing, but for Kubernetes world, where you can take revisioned, take the Kubernetes manifests and then revision them and bundle them together and just template how it will fit together. This is an example of how like the templating would look like. You have this values file section here, which is your as the name of values. It's like the entrance part for the chart, and what you describe here will be templated into the templates side of it. So here we have a deployment of YAML, but here we can just describe the parts of the YAML that we need to have be defined. And here you can just templaterize all the things that should be configurable, and you like leave the parts that are, let's say, should be a standard. You can just import that. Sorry. You can then embed that inside the template so that you can introduce your safety guardrails in that kind of a manner, where you just allow the configuration to be the sensible parts, and then you just let the parts that like don't need to be changed really to be left in the template. And then this is kind of how you can start creating standards for yourself in the Kubernetes world by making use of highly templated Kubernetes resources. So now we have like Helm charts and customized stuff all happening inside Kubernetes, and you have like ingresses to like define how you want all your traffic to come in, how you want certificates and all that stuff. Now you can bundle in all of that things as you like into your Helm chart, and then you end up with blocks defined for yourself. So now one of these blocks would be the entire, like in our little journey, we would have the service and the ingress and the deployment all contained in one of these blocks. So now if you suddenly need another customer that needs this kind of a block to be for their use case, so you can just take that Helm chart and just populate it with the correct unique values for that context, and then you get to comprise your type of environment a lot easier. And now that one has like some of these building blocks, you can now reuse those for like representative testing environments, where you can make it look and feel very similar to what a real production environment would look like, so that you can use it for training and education and testing. And then for the rare times when things go so bad that you need to disaster recover to a different place, now at least everything for how your workload runs, including other stuff, can be applied to another environment. And because it's all declarative and all bundled around your business's use case, then disaster recovery becomes a lot more painless and can be facilitated a lot more easily. Something that looks very interesting for the future is a tool called Crossplane, where just like so Crossplane is like piques my interest because you can define. So like in this one we saw that you could have a service to allow traffic to enter your pod. You can now define like a YAML structure that looks like that, but for let's say getting an Amazon RDS. So now you can abstract how you get your team's infrastructure by writing a certain YAML that would enable them to just say, give me a large database, maybe type MySQL size aggregates. And then the other kind of complicated, what kind of RDS settings you need to apply to make it sensible, it's encryption enabled, and all of that stuff you can facilitate behind the scenes by hydrating those templates from this little CRD resource that you've defined using Crossplane. And then now not just are you comprising and building those blocks for stuff that's inside Kubernetes, like a workload of like image running and networking stuff to get an access. Now you can also like give it the RDS for that stuff. So now you can add that RDS YAML into the little Helm chart block that we had earlier. And now when a team requests to have that Helm chart unpacked, now it will come with an RDS instance. And then this is kind of a way how you can enable teams to get more of the like vertical environment defined and all in like the same kind of YAML structure as like all the other resources, which is pretty wild to me, and that is making me quite excited for the future of Kubernetes as like a universal API for infrastructure and building platforms for people to consume, with like self-service kind of platforms for your fellow engineers to use. We're now coming to a close, and in the beginning we covered the journey of taking a very little pod all the way into Kubernetes, and then we looked a little bit at some of Kubernetes' components, how does its architecture look like, and its extensibility by being able to create it and extend its API with different kind of resources using like Crossplane and other kind of controllers. By abstracting away these kinds of things, it enables the developer teams and people to be able to just care about the problems that they need to worry about, so instead of really caring about how do I get my infrastructure together. And I think I resonate quite a bit with that as an idea, because not everybody really cares about how do I get cool infrastructure created in the most correct way that's like secure and all of that stuff. If we figure out how to make it secure, then we can make that the standard, and then people can say, just give me a secure database instead. And that's the kind of idea that I think is really interesting. Here are some useful links that I mentioned in the talk. And thank you very much for listening to my talk, and I hope you have a lovely rest of your day.